So let me go ahead and share my screen. And before I share my screen and before I talk to anyone, if anything embarrassing pops up while I have my screen shared, I apologize ahead of time. And I am warning you that you never know these things happen. All right. So let me present. So today I'm going to be showing off how to, first of all, hi, I'm JJ, Developer Advocate for the IBM Cloud. I really do have that email address of awesome@ibm.com. And you can go to find me on Twitter at JJ Asghar. Today, I'm going to be doing Kubernetes / OpenShift and show how to deploy a simple Python app to it. I have an OpenShift cluster on the IBM Cloud. The IBM Cloud. I'm going to probably drop that name a couple times, just a heads up. And hopefully you'll get some giggling out of it, and hopefully this will be a little bit entertaining. I'm trying to show some stuff. Please, if you have questions or thoughts, don't hesitate to put them inside the chat. I have no problem with stopping and answering questions as they come along. I should probably have the chat open. There we go. Okay, so first thing first is I'm going to set out the ground rules, or the ground vernacular for us to be able to speak about this. So I'm going to talk about Kubernetes and OpenShift. Then I'm going to bring up and show you some OpenShift. And okay, so the first question, what's the difference between OpenShift and Tanzu? So from what I understand about Tanzu in general, Tanzu is a rather large ecosystem of a lot of different applications. But there's Kubernetes, the Tanzu flavor of Kubernetes. Now, OpenShift is something that I will show off in just a moment where it comes into play. So don't worry about that. You'll see that in just a second. And then I'll show you my simple Python app that I'm very proud of. When you'll see it here in a moment. And then we'll deploy it to an OpenShift cluster, and we'll go from there. Okay. So let's start about some building blocks first to make sure that we're all talking about the same thing, to kind of play so we all have the same language to move things forward. First thing first, everything inside of the cloud native ecosystem using Kubernetes or OpenShift, everything is built off of something called a container. I recently learned from my IBM friends in the marketing org, I'm not allowed to use the Docker logo, but imagine the Docker logo there. There are multiple different offerings of ways to create containers. Podman, Docker, Builda, Canico. They all adhere to the OCI spec, which is the Open Container Initiative, I believe. They all need a registry somewhere to store, Docker Hub or Quay, or even OpenShift has a built-in registry. Everything's built from a Docker file, and it's the famous story, you package it up inside of a container, and as long as you have the container runtime, it can work. So that story that you've always heard from developers, well, it worked on my laptop, using a container allows you to package it up and then ship that off. So as you start shipping off containers to get things going, you need some way and somehow to orchestrate all those containers and all those different portions of hopefully your microservices-based architecture. If you are running a macro or a monolithic app, you can containerize a monolithic app, so don't worry. But you will need some way to orchestrate those containers. And that's where Kubernetes comes into play. When you look at Kubernetes as a very core entity of something, it is, in essence, just an orchestrator. It's a very bare bones and really good orchestrator for containers. The rest of the ecosystem, if you've ever looked at landscape.c and cf.io, has exploded with different things that Kubernetes doesn't answer. That's the reason why when you see that, it is overwhelming, to be frank. Most important thing to know about Kubernetes in general, community supported. There are some companies like IBM Cloud, just saying, that have Kubernetes offerings for you. But if you are, there is no real true upstream company for Kubernetes. It's all just open source work, and it's still very, very impressive. It's a core framework, limited security, and it is just really designed to do what it needs to what it needs to be done. And also to reiterate, there's no long-term support in front of it. So as you start using Kubernetes or moving into the cloud native ecosystem, you really do need to have your own practice around it. That you might not be paying someone to do it. You might have to do it yourself. there's a lot of things you need to think about. And that brings us to OpenShift. So to answer the question that was just brought up a moment ago, OpenShift is a progression-grade open source version of Kubernetes, and that's what I'm going to be showing off today. So it is all Kubernetes underneath the fact, but the beauty of OpenShift is that it's supported by Red Hat, and there is a true enterprise support behind it, just like you would have with RHEL. And there's some very strong opinions around how to interface with OpenShift. And hopefully in this presentation, you'll see the advantages of it. And I'll highlight some of the differences here just to make in a few moments to make sure that it works. The goal is to be able to move forward and get the velocity that you need for your business. And OpenShift does provide some really strong guardrails so you can focus on writing code instead of writing or building the infrastructure. So keep that in mind as we move forward. And please, again, if you have any questions or thoughts, I have the chat open. That's why I'm looking over to the right in the video, because I am waiting for someone to jump up and ask a question about it. So let's talk about some things we're going to play around with. It's true, IBM did buy Red Hat about a year ago now, which is pretty crazy if you think about it. And yes, I do have my little red hat behind me, if you can see it. That's a different conversation. I can tell at the end if we want. But I am an IBMer. So yes, deployments. Deployments are the smallest, or is how you tell Kubernetes or OpenShift. And as you see, I have Kubernetes and OpenShift down here at the bottom because they are in essence the same thing unless I call out specific OpenShift differences. A deployment replica is you telling Kubernetes or OpenShift, I need, in this case, 2 pod A's up and running. As you can see inside of the pod, you can have n number of containers. So you can have 1 container, like in pod E, you can have 3 containers, like for instance, maybe one's a Datadog log shipper or something like that, so you can get some information out of it. Or in the case of pod A, you have 2 containers that are doing something. A container in this case is, you should think of it like a process, and a pod is a collection of those. There's a lot of different opinions about how to do this. I'm not going to be talking about that specifically. I just want to make sure that you're aware of it. Let's keep going. So inside of, when you build up a Kubernetes cluster, an OpenShift cluster, as you can see, there are things called nodes. Nodes are just basically CPU. If you look at what the core is of Kubernetes and OpenShift, it's an API to compute. So when you say, hey, OpenShift cluster, or hey, Kubernetes cluster, run this pod, it finds and uses its own scheduler and finds a node that needs to be done it. The node runs something called a kubelet, and it basically sits there and waits for requests until it needs to run that container. So in essence, as a consumer of OpenShift or Kubernetes, we don't know what nodes are running what in general. The cluster is just running it. But the most important thing to realize about it is that there is anti and affinity rules on the nodes. So if you label a specific pod with needs to run on something with a GPU because it's doing ML, you can tell the label only run this pod on this specific hardware. It's important to realize you can do that. So let's talk about some internal concept of Kubernetes. If you've never seen it before, K8S is a short for Kubernetes. People say K8s, people say K8S, so there's a lot of different things, and OpenShift. So the first thing first, we all, as professionals in the IT industry, we all love DNS. So let's have some more DNS. And there is an actual DNS service inside of your Kubernetes and OpenShift cluster called kubedns. And this is how you would tell pod A how to talk to pod C or CTIC there. If it's looking for http/foo-web, it responds internally, and it will tell it, hey, go look at these pods, and the service will hand out to what it needs to be. It's a way to map up specific services to specific things. Also, there's another concept called namespaces it's really important to know about, which this is how you can logically cut up your Kubernetes or OpenShift cluster into logical groups. Now, in the grand scheme of things, namespaces are walled gardens. When you spin up my application or your application in this case, they do not know about each other. So take that one step farther, you can imagine you can have dev, QA, and prod all on the same cluster running the same hardware, but they can't cross cross out of their walled gardens. This is very valuable if you've ever had to deploy something to production where your dev environment is probably a VM sitting on your laptop, your QA environment is probably something under your desk, and your prod environment is probably this massive server somewhere that you don't see the difference between running it on prod and dev and QA. This allows for that. But I do also want to mention that people have learned to, for lack of a better term, abuse namespaces. So there is a way to cross-pollinate. But when you are first walking into this world, namespaces are walled gardens that they cannot cross unless you really do some interesting things. And that's something for a different conversation. Openshift has actually extended namespaces into something called projects. Now, the best way to see a project is if you are doing Git-based development, you probably are spinning out a bunch of feature branches and merging them back into main or master, however you want to call it. Well, imagine a project is one of those Git branches where you will iterate multiple times inside that project to get it to where it needs to be. And then when it's done, you export it out to, in this case, this payment prod. There are supposed to be some X's here, but good old slides ate my X's for some reason. If I was this developer in the center and I would have payment dev here, I would be iterating to get it to where I need to be. I wouldn't have access to catalog or inventory, but when I was done, I can export it out into some YAML files and then give it out to someone who has access to payment prod to make it happen. The best way to think of projects, again, is just like Git branches. They're ephemeral, but there are some long-lived branches out there. For instance, payment prod, you probably don't want to iterate on, but hopefully that makes sense. So when you talk to a service like that foo web service earlier, there are multiple ways to communicate to the pods underneath it. In this case, we're talking about a load balancer here, where this is actually, in essence, a professional grade load balancer there. So if you come from the outside world of the SDDC, for instance, and you probably know those F5s out there or the HA proxies or whatever, that level of customization and that level of development work, there is a software-built load balancer inside of your Kubernetes cluster. It really does, there's a million different knobs and dials to it, and it's really, really impressive. I strongly suggest looking at the docs for it, but know that it does exist. You can also rip out this load balancer if you need to, and put in your own, which I would strongly suggest looking at the documentation. The vanilla load balancer from Kubernetes is quite good. Okay, so we're not actually going to need to talk about ingress here, but the ingress, for the best way to communicate this to someone who's never seen this before, is how you would map your application from the ingress of the edge of your Kubernetes cluster to your application. The reason why I mention it is mainly because it turns out Openshift, one of the coolest parts about it, is this routes command. This routes command extends the ingress ability and turns it into like 3 commands where you don't have to mess with it much at all. You can just basically create my route, expose it, oh look, it's done, and I have the URL that I need. And if you've played with the vanilla ingress at all, there is a lot of YAML you got to figure out, and there's a lot of knobs and dials you got to learn how to get it to work, where when it becomes 2 commands and you basically just have this route of @prod.mycompany.com, it goes directly to our backend service. It is, you will see here in a moment when I bring up the Openshift cluster, it is extremely valuable to just have this alone. Okay, let's actually see some code and do some stuff. Before I go any farther, does anyone have any questions? Do you feel confused? Give me a +1 in the chat to see that people are actually listening to me. Maybe. I got a raised hand. That's a good sign. Perfect. Thank you so much. Awesome. Okay. So first thing first, just saying, here's IBM Cloud if you've never seen it, just saying. Yes, so yes, I believe it is recorded, and this is blazing fast. I completely understand, because I want to get to the point where I'm showing the code more so, and the beauty of running the simple app on Kubernetes. I wanted to make sure that you had at least a bit of a vernacular, so when I start talking about the terminology, you kind of see how it fits. But the beauty of it is that what I'm going to be walking through It's really not that bad. And you can also get your hands on to play with it too. But here's IBM Cloud with a Kubernetes cluster called Openshift AsgharLabs.io. I opened up the web console here. So this is actually the 4.4 version or 4.x version of the Openshift cluster. So yeah, a great question. Is there a personal or free version of Openshift to tinker with? So believe it or not, that's actually a really hard question to answer. But when I talk to people about it, what I talk to is, and I'll throw this in the chat also, is something called code-ready containers. And yes, I will share the code for the Python app in just a moment. Code-ready containers is the minimal OpenShift cluster to run on your local computer, where you can actually play with this yourself. Word of warning, it will melt your laptop. It requires a lot of stuff to run. So I strongly suggest looking into some research, looking into how people have ran it on a separate box and put HA proxy in front of it, so you have a way to play with it, but it will never be production ready. I should also say there is ways to deploy OpenShift into VMware clusters too. So you should do the research also. And okay, so, but if you want to just play with it yourself and you're not planning on gaming anytime soon on your laptop, code-ready containers is a great way to go. Okay, so here is a production-grade OpenShift cluster on the IBM Cloud. And you have multiple different options, as you can see here. I'm going to go over to the developer. And basically, as I was saying a moment ago, this is what a developer would see. Normally, you don't see the administrative way. You come in as a developer to see this. And what I'm going to do is, where is my code? Oh, no. Python. Okay. And I will put this also in the chat. So this is my beautiful production grade Python app. It runs Flask. And as you can see here, it says hello world. Yeah, yeah, good stuff, right? There's some pretty neat things about doing the health check, but we're not going to get into that conversation here. So one of the questions was, do you have a Docker image for OpenShift, just like we have for K8s? So I'm assuming you're thinking something like Kind or something like that to run Kubernetes locally. There's so much more involved in the OpenShift world and the way the licensing works. You have to really use something like code-ready containers, which is the link I put in the chat above. So as you can see here, I have my Hello World program. It's out on GitHub, so you can play around with it. I actually use this for a lot of different things. I show off Tecton and a few other things inside of it. I even started playing with Prow. But the beauty of it is it's a really basic, straightforward Python application running Flask. So normally what I would do is I would spin up my container and run it locally, but I'm just going to jump right into the specific side. Or you know what? How about this? We'll go ahead and just do Docker run or Docker build dash T VMware code latest period. I'll just go ahead and build it anyway, just to show that if I was a developer and I'm like, I'm going to build my container locally and it runs, cool. So I'm building it now with a Docker file. Here we go. And as we can see there, and then we can go Docker images, oops, -a grep VMware. And there we go. We see our VMware code. It was created 12 seconds ago. And I did it earlier for the video for y'all too, just in case I lost my internet access. So that's the reason why you see two. But if I do Docker run -it VMware or --rm VMware code latest what? Did I spell something wrong? VMware code. Oh, haha, oopsie. Fastest, my bad. There we go. As we can see now, this is just running my application on port 5000. So I can come over here and go to localhost port 5000, and we should see hello world. If I could only spell anything right today. Oh no. Oh, haha, my mistake. Dash P, port 5000, 5000 to 5000. Oh, come on. Show me some love here. There we go. Now that I've gotten here, 127.0.0.1. There we go. Hello world. And now we saw the actual call. So we know that I have now a container that runs on my laptop correctly, right? So now I could take this container, push it into my registry on OpenShift. But what I'm going to do is I want to show the build opportunities of it, where I'm going to hook up this GitHub repo to my OpenShift cluster and then tell it to build it internally and then run it. So we can actually see the things going on. And that's kind of the goal of what I wanted to show out of all of this, where if you go by exactly what the guardrails that OpenShift has, you could truly get some really awesome velocity out of this. So we come over here, and I'm going to do from Git because I want to pull this up from GitHub. So we can go here, and I will do the HTTPS build of it. So I will copy that URL, and I'll post this in right here. And then it is a Python. It's already figured out that it's a Python for me. Python 6. It's a deployment. And then we want to create a route. Remember that route I was talking about earlier? If you didn't have this, you'd have to figure out all the YAML for ingress. And this automatically does the route for me, which is phenomenal. So let's go ahead and create it. Uh-oh. Because I was testing, it didn't like that. So let's go ahead and change this to live. Sure, why not? Seems good, right? Hello, computer. Do your thing. There we go. Let's create it. So as you can see here, we pulled it. And then as you can see here, image pool, that's fine because our build is running right here. So if we come over to the logs, we should see pretty much the exact same thing that we saw earlier. Let's see. Come on. Show me some love. There we go. As we can see, now it's running. It's installing pip, just like we saw a moment ago. And then now it's pushing it into the local registry. And there we go, push successful. So now, if we go back to here, we see a nice big green checkbox. And we see also that our route is here. So if I should be able to go here, and something's not right. Oh, as you see, the services is pointing port 8080, unlike what I was doing earlier with port 5000. So let's go ahead and change this service to 5000. 5000. 5000. I will save it. Now we should see it kicking it and trying again. Why are you not doing what I want you to do? Give me 2 moments. I'm so sorry. Oh, there we go. This should be 5000. Save that. Come back over here. There we go. As you can see, hello world. Yay! Cool. All right, so now we know the same code that's running on my laptop has now been pushed into my OpenShift cluster and made that happen. But that's not interesting, right? Like that's just deploying a container. Let's actually make a change happen now. So if I go back over to the builds here and I look at the source, oops, the builds. Why are you not being nice to me? Go back here and bring up that. And then I come down here. As you can see, there's some built-in webhooks already. So I can go over here into webhooks here inside of my GitHub repo. I will delete this for now because that was my test from earlier. Command period. And I realize I only have 5 minutes left, so don't worry. I'm gonna make this. I'm gonna make it. I'm gonna make it. All right, Kripa. I got 5
You're
minutes.
You're gonna make
right?
it. You totally, yeah. Take your time.
Okay, cool. So I'm going to, as it says, it already has a GitHub one here. I'm gonna copy that URL as secret. I'm gonna paste it in here. I'm gonna change that to JSON, and then I'm going to add this webhook. And then I'm going to come and click on this guy, and I should see a green checkbox. All right, cool. So we know for a fact that now GitHub can talk to my Openshift cluster, right? Like nothing on my sleeves. Granted, I'm not wearing any sleeves. Nothing on my sleeves. This is all that good. So I'm going to come over here now, and we're going to have some fun. I'm going to go ahead and go to app.py. And you know what? VMware. Oops. VMware code. Why not? That seems like a reasonable thing to put in there. Oops. No. What? What are you doing? Okay, there we go. So I'm going to go ahead and, because I'm a bad developer, actually I could probably get a PR for my Hacktoberfest. So let's no, let's not do that. Okay, git add. Hopefully somebody giggled at that, maybe. I don't know. Git commit -m VMware code. How about that? That seems like a reasonable, it's not. I realize how bad that is. Git push origin master. Now, because we pushed it up to origin master, we will see, this also works with the PRs too. We already have the webhook kicked off. So then we should be able to over this builds here, and we should build here, come to this. And as you can see, it's already running. The logs are already, because of the webhook triggered, it's already doing the thing. We can come back to our logs, see what's going on, and making things kind of happen. There we go, pushed it in. Come on, push successful. And then, as you can see, it's doing a rolling update. Terminated, already did it. So if we click this link, VMware code, yay! So, and that's it. That truly is. Like I took a very basic Python application. Granted, it is very basic, but I hooked it up into GitHub. I made a change on my local laptop. I pushed it out, and because, well, obviously I didn't have any tests or anything, but Openshift automatically made the change, or took the changes in, rebuilt my container, and then deployed it. That's it. That's pretty cool, huh? And now just imagine where you can go from that, where you can truly do some really neat things. And that's all I got. Thank you, and please, if I can help you in any way, I'd be love to. Oh, just help. Oh, so Da Vinci. Oh, awesome! Thank you. I appreciate the like that's what you need to see, right? That's all you need to say. That's great. Thank you so much. Yeah, cool.
Awesome.
Please, if I can help, reach out. Kripa, you know that, right? Like,
yeah, definitely. I still, it's funny. I forgot that you're awesome at IBM. I still have your sticker on my laptop, literally.
Oh, so. That's awesome. That's awesome. I actually got in some trouble about those.
Oops.
Yeah. No, keep it on there. No, it's fine. I'm okay with that. I'm okay. It's just funny. It's just funny.
Great.
So.
Awesome. Thanks, guys. Have a great day. Bye.